Okay, welcome viewers. So we were solving this question in the last lecture that what is the truth value for all x this px is true and the px is given like this that x square is less than 10, and here we have the finite domain, okay, which consists of the positive integer not exceeding 4. So in this domain we have element 1, 2, 3 and 4. Okay. Now if I find P1, so I find that 1 is less than 10, so this is true. P2, for P2 I get that 4 is less than 10, this is also true. For P3 I get that 9 is less than 10, this is also true. For P4 I get that 16 is less than 10, which is false. Okay. So therefore P1 conjunction P2 conjunction P3 conjunction P4 is false. Okay, why it is false? Because this statement, this is false, and in case of conjunction we know that the result is true if all the values they are true. So but this, in this case, it is false. Okay, so therefore the truth value of for all x, this px is true, is false. Okay, the truth value for all x px is true. Okay, this truth value is actually what it is, a false statement. Okay, now the next question is this, that let px denote the statement x greater than 3. What is the truth value of the quantification that there exists one x for which this px is true? Okay, where the domain consists of the set of real numbers. Okay, so here what we want to do, we want to find a value of x for which this is true. Okay, we want to tell that value. You may take here 4 also. Okay, if you set x value equal to 4, then 4 is greater than 3. Okay, so what it is, it is true. Okay, it may be false for other values, but they are just saying that there exists some x for which this px is true. So we can say that there exists 4 for this, for which this is true. Okay, so here we can say that there exists some x for which this px is true. This statement is, the truth value of this is true. Okay, now the next question we now see that what is the truth value that for all x this statement is true. Okay, where the domain consists of the set of real number. Okay, so the px is x square greater than or equal to x. Okay, now you see here, if you set x value equal to 1 by 2, then 1 by 2 square, it is greater than 1 by 2, means that 1 by 4, it is greater than 1 by 2, it is false. Okay, uh, this is the case when domain is the set of real number. Okay, so for all x this px is true is a false statement. Okay, so this statement, it is a false statement. Okay, but when we want to consider the set of integer, okay, when domain is the set of integers, okay, then this statement x is greater than or equal to x. Okay, uh, the truth value, the truth value for all x this px is true is, okay, there is no integer for which this is false. Okay, So we can say that this statement is true for all x uh, px. Okay. Now next, this question we have already solved. Now next question, you see that you are given this statement qx such that x is equal to x plus 1. Okay. See, what is the truth value of the quantification that there exists x for which this qx is true? See, there is no x for which this is true. Okay. So this statement is false for every value of x. Okay. So there exists x for which this px is true. Okay. uh, this is false. Okay, this statement is actually a false statement. Now sometime you are given the domain. Okay, finite domain x1 x2 xn, when you have finite number of elements in the domain, then the existential quantifier there exists x px is same as the disjunction. Okay, px1 disjunction px2 disjunction pxn. Okay, and we say that this is true if any of the statement is true. Now you see this problem that px, which is x square greater than 10, px x square greater than 10. Okay, here domain is finite. Okay, in this domain we have elements 1 2 3 and 4. Okay, we have elements 1 2 3 4. Now what is p1? 1 square is greater than 10, so it implies that 1 is greater than 10. So this statement is a false statement. Okay. Now P2, what it is, 2 square is greater than 10. So means that 4 is greater than 10. This is also a false statement. Okay. Then P3, 3 square is greater than 10. Mean 9 is greater than 10. So this is also a false statement. Then P4, mean 16 is greater than 10. Sorry, 4 square. This is actually 4 square greater than 10 means that 16 is greater than 10. So this is true. Okay, so three statements are false and one statement is true, so we can say that p1 disjunction p2 disjunction p3 disjunction p4 is true. Okay, and this disjunction true mean that there exists x for which this px is true. This statement is okay. So these are the main examples of existential and the universal quantifier. I hope you people have learned these things, that how to solve all these problems. So more about it will be discussed in the next class. Thank you very much.